Okay, so essentially what we want to do now is solve these three equations. So I'm going to, again, define my matrix. And remember, I want to try to use the pattern that I defined in the last little video, where I basically have, my solutions over here, solution 1, 2, and 3. And then remember, I needed one equation with all three variables. And I said that that was going to be my first one. That's just easiest. Then I wanted one equation with just two variables. And then I wanted an equation with just one variable, right? So this is kind of what I'm looking to do. So now I'm going to basically just go ahead and use all the same properties of algebra that I was doing before to try to solve these things. So what I want to do first is just plug in my very top equation as is. And the reason is because I know I need three variables, so I'm just going to plug in what I have because it comes with three variables. So I'm going to plug in the 1. I have a negative 2 and a 3, and then my solution to that one is 9, right? So that one's good. So now what I want to do is I want to focus on the second equation here. But bear in mind that I don't want the x variable anymore. I want to find a way to cancel him out so that the only thing I'm left with is a y and a z, okay, based on what I've got going on over here on the right. I just want the y variable and the z variable. So if I take negative x plus 3y, and I'm going to say plus 0z because we have a 0 coefficient on our z. That's equal to negative 4 right now. Which one of these equations can I combine it with in some degree to try to cancel out that x? Well, the most straightforward one is going to be the first one. So essentially, I just want to add that first equation. So I'm going to add x minus 2y plus 3z equal 9. And then whatever I get from this addition here, I'm going to take and I'm going to plug in for my two missing pieces here and here. Okay, and I'll show you what I mean by that. So go ahead and just do the math. So negative x plus x is 0. So I get a 0 for my x coefficient. Then 3y minus 2y is just 1y. And then 0z plus 3z is just 3z. So I have a 3 that goes there. And then negative 4 plus 9 is just positive 5. So my 5 goes right there. Okay. So far I've accomplished my task. I have ones along the diagonal so far, and I have a 0 here for my x, indicating that I canceled it out for that equation. All right. So now I kind of want to do, actually, I want to do exactly the same thing for my third equation, except I don't just want to cancel one variable. I actually want to cancel two of them, right? Because I only want one variable from my last equation. I only want to find the value of z, right? So if I want to find the value of z, that essentially means that I need to cancel out that 2x, and I also need to cancel out that minus 5y. So let's think about this for a second. So I have 2x minus 5y plus 5z equals 17. So that's my equation as is. Now typically it's not going to work out quite so well that I can just cancel both of them simultaneously. I really am going to need to cancel the x first, get an answer, then from that answer I'm going to want to cancel the y, and then I'll be done. So it's kind of a two-step process for this one since I'm canceling two variables. So if I look at it, which one of these three equations is going to help me in canceling out? We'll first cancel out the 2x, right? So I can see pretty easily that if I take this first equation and multiply it by negative 2, and then add it to this guy down here, that then I'm going to have negative 2x and positive 2x, so my x's are going to cancel. So I think I want to do that. I'm going to take this whole top equation here, and I want to multiply everything by negative 2. So I'll have negative, so I'm going to have negative 2x, and negative gives me a positive 4y. And negative 2 times 3z gives me minus 6z. And negative 2 times positive 9 gives me negative 18. Okay, so I want to take and add these two things together. So negative 2x plus 2x, well, boom, those cancel. That becomes a 0, so I can fill in a 0 there, which is good because, again, the whole point of this was to cancel out the variables that I don't need and just get it down to 1, right? So now I have 4y plus negative 5y, which gives me minus 1y. So that's minus 1 that's going to go in that spot. So now I have negative 6z plus 5z. Well, negative 6 and positive 5 just gives me, oops, negative 1z. Okay, and then negative 18 plus positive 17 is negative 1 again. So I kind of have this going on. So I kind of have negative 1y, negative 1z, and negative 1 as my solution. Now again, remember my rule about the diagonal, right? The whole point was so that everything on the diagonal, which if I kind of sketch it here, so this is my diagonal. I want everything on this diagonal to be 0 if it's below the diagonal, or 1 or some other number if it's above the diagonal, right? Well, the problem is I've got this guy right here. I need to get rid of him, or he needs to become a 0. So I want to then take this equation here, this guy, this negative 1y minus 1z equals negative 1. I want to cancel out that y so that all I'm left with is z. Okay, so what equation can I combine it with to cancel that out? So let me erase some of these just so we can see what we're doing here. So if I want to cancel out negative 1y, well, I could, and there's a bunch of different things that I could do, but what I'm going to do, if I can pick the right color here, is I think it would be best if I maybe take this top equation and multiply it by negative 1/2. Negative 1/2. And the reason is because if I multiply that guy by negative 1/2, what do I get? And while this might seem like the most logical thing, if you notice, the negative 1/2 is going to end up giving me a positive 1y, which will cancel with my negative 1y down here. The problem is that it's also going to reintroduce, let's see, where's my pen? It's going to reintroduce this x term, which I just worked so hard to get rid of. So that seems like the logical first step, right? But that's actually not going to work. So now let's go to the second equation. Well, again, I've got the same kind of problem where I have an x and a y. I could maybe use that y to cancel out that way, but then it's going to reintroduce an x. And the same with the third equation. So what I can do is I can go back up to this equation up here. So remember how I was plugging all these numbers in these placeholders up here? Okay, the reason why I'm doing this is I'm basically rewriting each of these equations to something that's equivalent. Okay, so this equation, the second one here that's written in blue, is essentially 0x plus 1y plus 3z equal 5, right? That's 5. Okay, that's what this equation in blue is right here on the second line. So since that guy is mathematically equivalent to the original one, I can actually use this guy right here. And the nice thing about that is that it's going to cancel my y's, but it's also, because I've already made the x value 0, it's not going to reintroduce that 0, which is really the thing that I'm trying to avoid. So I'm going to actually go ahead and use that guy. So we'll go back to my purple here. So 0x plus 0x is 0x, which is good. That's what we want to keep. And then we have 1y minus 1y. That becomes 0y. So now I can change this guy in my table to a 0. And then I have 3z plus negative 1z, or 3z minus 1z. So that leaves me with 2z. So I'm going to now change this guy. His value is going to change to a 2. And then I have 5 minus 1. So that's going to give me a solution to this guy of 4. So then once again, I want to just kind of make all the changes that I need to make. And that guy becomes 4. So let's just kind of recap here what we did. I can erase some of this stuff. Okay, so essentially what I did was I solved for my z value. Okay, so, and actually I don't have my z value yet, we'll get to that. But so essentially at this point, I started with my first equation. I left that guy alone as is. My second equation, I went through and I found a way to eliminate the x value, right, so that I could get a 0 here. Let me use a different color. So I could get a 0 here, right? And then I left it just written in terms of 2 variables. It's still an equivalent form of the equation. It's just now written in terms of 2 variables, the y and the z. Okay, then my third equation, I canceled out the x, I canceled out the y, so that I could have something written just in terms of z, which is what this 2 represents here. Okay, so essentially, if I do my diagonal check, I can run my cursor along the diagonal, and I can see, oh hey, I have only numbers above the diagonal, which is good, that's what I want, and I have only zeros below the diagonal, which indicates that these are my variables up on top here, and these are my things that I had to cancel out to get those variables on the bottom. So far everything looks good. So there's only one last change that we have to make before we're completely finished and we can solve this thing. And I'm going to go ahead and pause it and do that as another video. Okay?